Hey everyone, Mr. Herc here, and today we're going to be going over AP Pre-Calc Lesson 3.4 and 3.5. Let's get right into it. All right, so here's the bell ringer for today. Find the following values: cosine 30, sine pi over 3, cosine 180, sine 7 pi over 4. So taking a look here, if we draw out just our first quadrant, we can use this to answer the rest of these. So this should be 1, 0, 0, 1, drawing our other three angles 30, 45, and 60 degrees. Here, you know it's root 2 over 2, root 2 over 2. This should be root 3 over 2, comma 1 half. And then this would be the inverse 1 half, comma root 3 over 2. And so cosine of 30 degrees is going to be our first coordinate, right? Our x coordinate there, because it's cosine comma sine. So this should be root 3 over 2. And then sine of pi over 3 is 60 degrees. That should also be root 3 over 2. So those are our first two there. Cosine of 180. 180 degrees is right here. This coordinate is negative 1 comma 0. So the cosine value, the x coordinate there is negative 1. And then sine 7 pi over 4, that's going to be right here, which is going to be a 45-degree reference angle. So we're going to take our 45-degree sine value, which is root 2 over 2, but then you want to make sure that it's positive or negative correctly. So here in the fourth quadrant, only cosine is positive, which means this sine is going to be negative. So that should be our four answers there. Now, graphing sine and cosine. So far, we've learned how to find the sine and cosine value for angles, how to measure angles in radians, and how to use the unit circle to evaluate sine and cosine functions at a given angle. And we're going to put all of these concepts together to help us graph sine and cosine on an xy coordinate plane. So let's start by considering just the equation f of theta equals sine of theta, or this is very similar to y equals sine x. We know that angle measures in standard position are periodic, right? Because like 30 degrees will appear the same as 390 degrees. You go another revolution around, that will appear the same. And so we can expect these functions, these are going to be the same in this case, to be periodic as well. So let's take a look. The angle measures from the unit circle can give us several convenient input values to use in our horizontal, our x-axis. So let's evaluate these. You can use your unit circle that you had from last class. And so filling this out, you should get 1 half here, root 3 over 2, 1, root 3 over 2, 1 half, 0. So I'm just going to kind of speed through this. Negative 1 half, negative root 3 over 2, negative 1. There we go, and then 0. And now converting these to decimals, you would get a calculator for this part, but 0 0.5, 0 0.87, 1, 0 0.87, 0 0.5, 0, 0, or negative 0.5, because it's negative now, negative 0 0.87, negative 1, negative 0 0.87, negative 0 0.5. And so let's actually graph that now. And so here, we're going to start with at 0 degrees, sine of 0 is just 0. Sine of pi over 6 is 1 half. Sine of pi over 3 is around 0 0.87, so it's going to be around here. Pi over 2 is 1. Graphing the rest of these, this is what you should get. And so if we connect this all together, it should look a little something like that graphically. And so this is what the equation looks like. And there's some things I want to point out here. We'll learn what these things are, but here it has a midline at 0, meaning that like line of, kind of not line of reflection, but the line that cuts it in half is going to be at y equals 0. Its period is 2 pi, so every 2 pi from 0 to 2 pi, it will repeat itself, and this will continue on forever. And then its amplitude, the distance from the max to the midline, and we will learn more about these in depth later, is 1. So this distance has uh, a distance of 1 there. All right, so let's do the same for cosine here. This is going to be also requiring the unit circle. So I'm just going to fill these in. Root 3 over 2, 1/2, 0, negative 1/2, negative root 3 over 2, negative 1, 1, 0, 1/2, 3 over 2. There we go. And then converting each one to decimals, 0.87, 0.50, negative 0.87, negative 1, negative 0.87, negative 0.5, 0, 0.5, 0.87, and then positive 1 there. And so now that we have that, we want to now just graph it like we did. So here, cosine of 0 starts at 1, and it's going to end at 1. And then just graphing this, pi over 6 should be 0.87, 0.5, 0 at pi over 2, and then so on and so forth. So let's do that now. So that's what the graph of cosine should look like, which means graphically that's as best of a line as I can get. And so that's what it should look like graphically as well, which means it's going to look like this general shape, where at 0 it starts at 1, goes down, and then comes back up. It has the same amplitude, midline, end period, though, as sine, and so that is important to note as well. And so notice how the period of sine or cosine is 2 pi, the amplitude for both of these is 1, and then the midline is 0. And so we're now going to look at key characteristics, amplitude, midline, and period, and learn at least 3 things about each characteristic. We want to know, what is it exactly, how can we identify it from a given graph, and then what is that characteristic for either sine or cosine. And we'll also cover 2 other things as well, which is going to be the b value and the starting point. So let's start with amplitude. Amplitude is going to be the distance from the midline to the max or the min. So for example, if we have something like this and our midline is right here, and then this is our max, or you could take the min here. Either one, this should be the same because the midline cuts it in half. If this distance is 7, then this one is 7, and that is our amplitude, is equal to 7 in this case as well. And so basically what you can either do is look at this distance right here to get 7, or you could take the total height of the graph, which in this case would be 14, and divide it by 2 to get your amplitude. So let's start by finding the amplitude of these following functions. So here our midline is going to be at -2, our maximum is at 1, our minimum is at -5, so -2, 1, and -5. So here, this is 3 apart, this is also 3 apart. So our amplitude for this function should be 3. Our amplitude here, if this is our midline, is just 1, 2 spaces. So 2 should be our amplitude for that function right there. And then for sine and cosine, our amplitude for these are just going to be 1. It's the same, and it will always just be for those 2 parent or basic functions. The period. The period is going to be the length it takes to complete one cycle. And so it doesn't have to be like sine or cosine, even though that's what we're only going to look at today. And so there's a few things to find the period. You can find a key characteristic, such as maybe the maximum there. That is going to be the length of a period. So this could be, let's say, like 3 pi, and that is your period there. It could also, it doesn't have to be in terms of pi though. It could be a period of 11, and that's your period. What you could also do is look at a key characteristic such as it being at the midline and maybe going down there. So this is the next time it does that. This distance would then also, in this case, be 11 as well. And so really just look for one key specific part of the graph and then just kind of go from there. So finding the period of these functions, let's take a look. It's hard to estimate where is this going to be in terms of our x value. So instead, I might actually want to look at the midline. So here I see the midline at 0. It starts at the midline and goes up, and it does that again at pi. It starts at the midline and goes up, and then that's when it starts to repeat. So from 0 to pi, our period here should be pi. Taking a look here, we see a maximum at pi, and we also see a maximum at -3 pi. So the distance there is going to be a total of 4 pi. So 4 pi is going to be our period for those two functions there. And then for sine and cosine, the period will be the same. It's going to be 2 pi, and that is because that's just one full revolution around the unit circle, which means after that, our sine and cosine values will start to be the same again. Midline. The midline is technically halfway between your max and your min value. It's a horizontal line, so when you write, like if I ask for a midline in the next example, you could either write y equals the midline, or you could just write the midline as like a number. Either one is fine. I'm not going to be too nitpicky about it. But basically, take your max, take your min, and then divide it by 2. So for example, if you have a min at -12 and a max at 6, you would do 6 plus -12 over 2, which is -6 over 2, which means at -3 would be your midline there for a periodic function. Right, so find the midline of these functions here. So we have our max at 1, we have a min at -5. So 1 plus -5 over 2 is -2. You can also sometimes just tell graphically or visually that your midline is at the point that it's at. So here, y equals -2 or just -2 is good for h of theta. For f of theta, you can also kind of see this pretty clear visually, which is at -1. So that should be our answer there. And then our midline for sine and cosine are, again, both the same. It's just going to be y equals 0 for both of those there. All right, the next thing I want to get into is the b value. This is going to be a new concept and not really taught a whole lot, but it is really important. The b value is going to be 2 pi over your period, which means your b value could be really weird depending on what your period is. For example, if your period is 7, then your b value is going to be 2 pi over 7. However, let's say your period is 4 pi, then your b value is going to be 2 pi over 4 pi, which is 1/2 as your b value there. So you could have your b value in terms of pi or as just a rational number like that. The b value of sine and cosine is going to be 1 because the period is 1. So then 2 pi over 2 pi will always be 1 there. So let's find the b value here. If we take a look, our period from this, remember, was pi. This was pi units apart. So then 2 pi over our period will get us a b value of 2. Here we learned that our period was 4 pi long. So then doing 2 pi over our period got us a b value of 1/2 there. And then our b value of sine and cosine, like I said before, is just 1. So pretty easy there. Our starting point. Our starting point is where you would typically start graphing the function. For example, if you were to graph like an absolute value function, you would probably start the graph at 0, 0. That's where I started drawing that graph. And so this is going to be where we kind of start drawing the graph for a sine or a cosine function. It's going to differ between each one. And so there's going to be infinitely many different starting points that you could have, which means in some of these questions, especially in the short answer questions that you'll come across later, you can have multiple different answers for your sine or cosine starting point. So typically though, for sine, so let's take a look. Here we have sine and here we have cosine. We'll do sine first. So the sine starting point is going to be at 0, 0. And this is because it wants to be, for sine, it needs to be at the midline and it needs to be going up. So 2 pi comma 0 would also work as well. But as long as it's on the midline going up, that's all that matters for a sine starting point. For a cosine starting point, it's a little bit different. It's going to be at the peak or maximum going down. And so here it would be at 0, 1 would be our cosine starting point there. So you will need to be able to look at a graph and identify a sine and cosine starting point, as well with the midline and period and everything else that we've learned so far as well. So let's try example 7. Find a sine and cosine starting point for the following functions. So for 7a, our sine starting point is going to be at the midline, which we know is -2, and going up. So maybe right here, this one looks good. So this is going to be 0, -2 as our y value. And that's our sine starting point. Our cosine starting point is going to be at the maximum going down. And that one's kind of labeled for us. And so that should be pi over 4, 1. Our sine starting point here for b is going to be at the midline going up. So here we should have 0, -1. Now take note, 2 pi comma -1 would not be a sine starting point because it's at the midline going down, not going up. So this would not even be in contention. Our cosine starting point is just going to be at the maximum going down. So here, a good cosine starting point would be pi comma +1 there. All right. Now, sinusoidal functions, it's a weird word to say. It's basically any function that involves an additive or multiplicative transformation. So just think of any transformation that we've learned about on sine of theta. And so sine and cosine are going to be the same function, except one has a horizontal translation. So if we take a look, this is the graph of sine. Let's draw a few more periods here. So this is the graph of sine. Now let me sketch the graph of cosine. So cosine is going to look like this. Let me draw a few key points. And then in between. Good. All right. So cosine should look like that. Not perfect, but yeah, that's my best drawing of both of those, where this is going to be cosine, and then this right here, that red line is going to be sine. If you think about it, if we took every point on this sine graph and we moved it left pi over 2, then you are going to get cosine. And so this really is the same graph, just a horizontal translation from sine to get cosine, or from cosine to get sine, whichever way you really look at it. Example number 8, 2 periods of the sinusoidal. So one thing that is important to note is when I use this word, it doesn't mean it has to be a sine function. It could be cosine. Sinusoidal applies to both of those, are shown in the figure above. Find the period, b value, amplitude, midline, and then 2 sine starting points for this graph. So let's take a look here. Our period is going to be, we want to find a key feature. So I take a look, I see at the midline going up there, with this kind of being our midline, and then that same thing at pi. So from 0 to pi, that's going to be our period, which means our b value is going to be 2 pi over our period, which is 2. Our midline is going to be the line that cuts it in half. That's going to be at y equals 3, or just 3. And then our amplitude is going to be the distance from the max to the midline. So that's from 6 to 3. So 6 minus 3 is 3 there. So that should be our answer for example 8. Example 9, find 2 sine starting points. So I actually have them labeled right there. It's going to be this green point right here and this point right here where it's at the midline and it's going up. So this is going to be 0, comma 3, and then pi, comma 3 as well. So that should be our two answers there for example number 9. All right, example number 10 and 11. Here we want to find the same four things and then find two cosine starting points this time. So our period, we are going from a max at 0, and then the next time we see that max is at pi over 2. So from 0 to pi over 2, that's just going to be our period, is pi over 2. Our b value is going to be 2 pi over 2. So just be really cautious with your fractions. This is 2 pi over 1 times the reciprocal, so 2 over pi, which means our b value here should be 4. All right? Now that we have that, our midline is going to be, where is it in the middle? Here it goes from positive 3 all the way to negative 1. So 3 plus negative 1 over 2 is going to be 2 over 2, which is 1. That's going to be our midline here. So let me draw that on there. And then y equals negative or positive 1. Whoops. Should be our answer there. And then our amplitude is the distance from 3 to 1. That's just 2 units tall. So that is our amplitude there. And then our cosine starting point is also going to be these two blue dots. So at 0, comma 3, and then at pi over 2, comma 3, those would be our two starting points for cosine. All right, example 12. This is going to be what happens when I give you a maximum and then a minimum. What I would recommend is doing a rough sketch and then using this to help you find the period and b value. Take note that for a sinusoidal function, when you have a maximum and then you have, so this is like one full period, and then you have the minimum there, the distance from the max to the min is going to be half a period, because then it's going to take the other half of the period to go from the min to the max. And this is with any sinusoidal function. Doesn't just have to be like cosine x or sine x. Taking a look here, so if we sketch this, we know it has a maximum at the point 0, 24. So let me almost like kind of label that 0, comma 24. And then the first minimum value is pi, comma 10. So let me label that as well, where this is pi, comma 10. So this is what our graph will look like, where this is only going to be half a period. So what is our full period? If our half a period is from 0 to pi, our full period would be from 0 to 2 pi. So 2 pi is going to be our period there. What is our b value going to be? Our b value is going to be 2 pi over 2 pi, which is 1. So that would be our b value there. Our midline, here is now where we look at our coordinates, our y coordinates specifically. We have a maximum at 24 and then a minimum at 10. So our midline should be 24 plus 10 over 2, which should be 17, right? 17 is smack dab in the middle. So that's going to be our midline. And then our amplitude is what's the distance from 24 to 17 or from 17 to 10. It should be the same distance there, which is 7. So that's going to be our amplitude for example number 12. And then for example number 13, this is what you could see or what you will see on the AP exam, where I will give you a story problem. You will have to find the 5 coordinates, and then you will have to answer questions about the actual graph. So I gave you the 5 coordinates here. We are given that f is 0, 128. So you don't have to do this question again. G is 7.5, 120. J right here is going to be 15, 112. K is 22.5, 120. And then P is 30, 128. So those are like the 5 coordinates. We're going to assume that they're going to be correct here because they are. And so let's take a look. Find the period first. Here, the biggest thing for the period is going to be looking at those maximums. We're going from 0 to 30, so our period here should be 30. To find our b value, it's just going to be 2 pi over our period, which should simplify down to pi over 15 as our b value. Our amplitude is going to be from the midline, which is at 120, to our max, which is 128, or from 120 to 112. Either way, you're going to get a distance of 8, so that is going to be our amplitude there. Midline, I kind of already said this. It's going to be that line in the middle, which is you're going to look at the x-coordinate for either g or k. That's y at 120, so that is going to be our midline there. And then a sine starting point. This is going to be at the midline going up, and so that is going to be at 22.5, comma 120, which is going to be k's coordinate there. And then cosine starting point, you could have two. You could either have f or p's coordinate, so either 0, comma 128. That's what I would recommend going with, or if you wanted to, you could have 30, comma 128 as well be your two coordinates for a cosine starting point there. All right, so if you have any questions, please come see me in office hours, and I will see you guys later. Thanks.